Hey everyone! So we've run into our first little hiccup of the year. As you have heard, we are not meeting in person today, but I will be giving you exactly what you are going to see today through this video. So, sorry I'm going to be looking here a lot because that's where I'm writing. I know my camera's over here, but so got my college shirt on for Wednesday. Just keep that in mind. I'm trying my hardest. In class today, what were we going to do? We were going to add to the Google slide that you did yesterday. If you'd like to do that, the prompt is still up there. I've added my GIF up there. If you'd like to do that today, you're more than welcome. If you skip today, that's okay too. We were going to go over homework questions if you had them. So that will have to get pushed back to Friday. Or you can contact me today and I'll still help you out. I am still available today. We're just not meeting as a whole class at the same time. So if you need some help, send me an email. I'll try to be on office hours. I might send some times. I haven't decided. This is a Tuesday night right now. So I haven't decided what times that I will be on my office hours Zoom link. And I'm hoping we're allowed to meet there. So let's have that in our back pocket if you need some help and you tried your homework yesterday. So I'm going to go through our notes, follow along. You will find the skeleton notes of the blank copy and the completed ones already on Google Classroom. I'm going to run through them. As you can see, I have my calculator ready to go. We are going to need a calculator today. If you do not have one, check the link at the top of the materials for Google Classroom. You will notice how to access the TI-84CE Chrome app. There's a little video for you to watch from Mr. Corney. He's going to show you exactly where to find it. So if you need to use your Chromebook for that, you have a graphing calculator app on there. So without further ado, and without this video being so long, let's get into it. How to use a graphing calculator, a graphing utility to solve equations. Our first example, x cubed minus 8x plus 1 equals 0. This is not something we can factor. This is not something we use quadratic formula for. This is not something we can simply get x by itself and move everything to the other side with. We can't do that. So something like this, we got to use a calculator. So I'm going to show you my typing stuff, and then I will write it all down. So the first thing you got to do is go to your y equals, clear out anything that's already in there. Let's see. I'm going to type in x cubed minus 8x plus 1. That is the thing that we're trying to figure out when it is equal to 0. If you look at the graph, if you hit the graph button, looks like there's a couple places where that happens. But if you look closely, they're not at whole numbers. So how do we do this? The first method, and they're both going to be found in this trace guy. You have to hit second, trace to bring up our calculate menu. And when we have something equal to 0 and we want to solve for the values that make that happen, we're actually going to just go to 0. Now the calculator is going to give you 3 prompts. It's going to say left bound, right bound, and then guess. Left bound means you move your cursor to the left of what answer you want. So you notice this cursor is to the left of this answer. I'm going to hit enter. I'm going to move it past the place where I know an answer is. I'm going to click enter again for my right bound. You will see very lightly these 2 lines. Our answer is in between them, which is a good thing. And you're going to hit guess, move the cursor kind of close, and the calculator will tell us our answer. So one of our values is x is approximately negative 2.8. Let's round to 2 decimal places, 9. So I'm going to skip finding the other 2 and write down, again, the buttons you press to do this, and I'll also write down the answers you should get, but you should try to see if you can come up with the other two without watching me do it. So the buttons to find a 0. To find 0, aka the x-intercept on a graph, you're going to hit, after everything is in y equals and all that, you're going to hit second, trace, and then you're going to go to, what number is it? You're going to go to 2, 0. And then you're going to have to answer the left bound, right bound, and guess. So I'm hoping that you've done that before. That makes sense. You remember how to do that. If you're going to try this yourself and you haven't yet, make sure to pause the video, because I'm going to write down the 2 other values you get for x when you do that same calculator move to find the other 2 places where it crosses the x-axis. We get x is approximately negative 0.13, and x is approximately 2.76. Okay. That is one way to do this. If you'd like another problem to try out, here I'm going to write it down for you. So something for you to try all on your own if you like. I'll leave it there for a second. You want to try it? Pause it. You want to see how to do it? I'm going to show you just a quick way. To use the calculator in the same way, if you're going to use the calculate 0 thing from the calculator, it's got to be equal to 0. So the first thing you would want to do is to rewrite this so that it is equal to 0. Now, you could do the calculator thing, for sure. You can look at the graph, you can do that. But this is also factorable. This is something we can solve by hand, so I'm going to ditch the calculator for a second. This factors to x minus 9 times x plus 2, which means our solutions are x equals 9 and negative 2. I guess I should write my intermediate step just in case here at the beginning of the year. Make sure to set each of the factors equal to 0. There is one thing that I want to show you from this answer, is another way to write a solution. So our solution set we can write as 9, 2 with the curly brackets. So this would be an acceptable answer. You'll see that on Math Excel. Sometimes it wants you to write it like this. One way that it's definitely not. If you were to write that with parentheses, that's a no-go. That's a point. That's an x comma y. We can't do that. If you're giving me a set of numbers, use curly brackets, and we can do that when we have multiple solutions. All right, I'm hoping we're feeling good. This is straightforward. Method number 2 is not to find the 0, but to find intersections. So I'll rename this 1 because we're doing a different method now. Let's solve 5x squared equals 13x plus 6. Now, this is a quadratic. We can move everything to one side so that it equals 0. I don't think... No, this one actually is factorable. You could factor it. You could use quadratic formula, but let's use the calculator to do this one. So another way to solve equations using a calculator is we're going to use intersect. But to use intersect, that means we need 2 things that we're looking for where they cross. So we're going to go back to y equals. Instead of setting everything equal to 0, we're going to take the left side and make that one of the things we graph. So see my 5x squared. The other one, we're going to do 13x plus 6. There's the other side. There's the right side. If we look at the graph, we're looking for the 2 places where these 2 graphs intersect. And we can't see both, but if we imagine looking up here, there's going to be another place where they cross. I guess I should say it doesn't have to be 2. And then we're just looking for the x values because we're solving for x for this problem. So how do we do the calculator moves for this one? You're going to hit second, trace, and instead of 0, we're going to do intersect, which is 5. Now the questions for this one are a little bit different. It's going to say first curve, second curve, and guess. First curve means that it wants you to tell you which function it's looking at. So right now, the numbers are blue, the cursor is on the blue function. I'm going to hit enter. That's going to tell the calculator, I want the first function we're looking at to be the blue one. So you can see after I hit enter, it changes all to red and the cursor jumps over to the other graph. That's telling it that I want the calculator to look at this function and I want the calculator to look at this function, and it's going to find where they cross each other. It's going to ask for a guess. Move your cursor close to the answer to get the right one. So one of our answers happens to be, and I'm going to write it as a set, -0.4. And to find the other answer, we actually don't have to expand our graph screen. You could, but you don't have to. So I'm going to do the exact same thing. Second trace, intersect, blue curve, red curve. This time for the guess, though, notice I'm moving my cursor over to the right. It's going to move out of the screen. I'm just going to keep moving it a little bit further because I don't know how far I have to go, and then I'm going to hit enter. And it tells me the other intersection point is 3,45, and we're just looking for the x. So our other solution is 3. Another way to write that, x equals -0.4. And 3. Let me write down the keys again. Second trace, and then this time it's 5 intersection, or intersect. And then it's first curve, second curve, and then finally guess. All right. This video is getting a little long. I'm almost done. Maybe I shouldn't say that. Maybe that's going to give you false hope. A second problem for you to try if you want -x⁴ plus 1 equals 2x squared minus 3. I'm going to tell you to take a look at the completed notes for the answer if you try that one out. But I recommend trying out the intersect function on the graphing calculator with that one. All right, switching paper. Now we're going to do some things by hand, talk about how we do these. I'm just going to go through the examples on the notes, even if some of them are maybe a little easier, a little bit more straightforward, and I got to make sure that you can see where I'm writing. So, solve algebraically, no calculator, by hand. 5 minus the quantity 2x minus 1 equals 10 minus x. I'm going to say you should be able to do this. Try it out. Pause right now. Get your answer. I'm going to write it down in a second. But you do this without me. I'm not even going to write the work. I believe in you. You can do this. Pause if you don't want the answer yet. X equals -4. I'm going to let you do that one. The next one I am going to talk about a little bit because this is a handy dandy math trick. 5 over y plus 4 over y equals 3. Man, is it a pain to deal with variables that are in denominators. So I'm going to give you a hint. You want to get rid of denominators? We can multiply an entire equation by denominators to get rid of them. I want to get rid of the denominator, which happens to be y. Why don't I just multiply everything by y? If I do it on both sides, it's not changing the equality statement. It's still equal. 5 over y times y, that's just 5. 4 over y times y, that's just 4. 3 times y, that's 3y. From there, man oh man, that's not too bad. Get rid of denominators by multiplying through everything by the denominators. We're going to see that one more time with this next example, which takes the difficulty level from number 2 and goes way up. But it's still not too bad of a problem. 2 over x plus 2 plus 3 over x minus 1 equals -8 fifths. You don't like denominators and you want a trick to get rid of them, even when it looks like this. Here's what you're going to do. You're going to take the entire equation and you're going to multiply by x plus 2, x minus 1, and 5. If you multiply by all of this, this will cancel the denominator in every single part. And I'm going to be a little bit more specific on this one and write out exactly what's happening. We're taking this first one, 2 over x plus 2, and we're multiplying that by x plus 2 times x minus 1 times 5. What cancels? the x plus 2's. And what are we left with? 2 times the quantity x plus 1 times 5, which is 10x minus 10. I hope I'm doing that right. Sorry if I made any mistakes. I think I'm okay. We look at the second one. We take the second term, second expression, and we're multiplying it by all 3 of those things that were denominators. So we're multiplying it by x plus 2, x minus 1, and 5. And what happens? Doing this, we've canceled the denominator. Now, just be careful. Make sure to write this out if necessary. Think about what's canceling. We're going to do 3 times x plus 2 times 5. So 3 times 5 is 15. Times x is 15x. 15 times 2 is 30. And there's a plus sign in between those two things. There's that plus sign. So now we have 10x minus 10 plus 15x plus 30. We don't have any denominators. Now the last one's a little bit trickier. We're going to have negative 8/5, and we're multiplying that by x plus 2 times x minus 1 times 5. And this time the 5's cancel. So this one requires a little bit extra work. Multiplying out these binomials, we get x squared plus x minus 2. Then you have to multiply them by negative 8. So what do we get? We get negative 8x squared minus 8x plus 16. Now this equation doesn't have any denominators, and for maybe most of us that's going to feel easier. So if you like that way, I don't know what other way you'd really do this. I guess we combine like terms on the left by making common denominators, then maybe cross multiplying. You'll get to the same place though. This would be a good place to pause, do some work. This one is factorable, and if you can't factor it, maybe try quadratic formula. Or I guess you could use a calculator, even though I told you I wanted you to do these without a calculator. But I'm about to run through the steps real extra fast. So if you want to try this one on your own, pause and try. Let's see, what do we get? We get 0 equals negative 8x squared. Actually, you know what? I'm going to move everything to the left. 8x squared, 25 plus 8. Plus 33x minus 10, that's 20, minus 16. Is that plus 4? Equals 0. This happens to be factorable. I know you might not be able to tell by looking at it, but you could always use quadratic formula. This factors to what? 8x, 4x plus, and then a plus 1. So our two solutions, x equals negative 1/8 and negative 4. Or if you were to write the set of solutions, we would put those two numbers in curly brackets. Okay, I'm at 18 minutes. I'm sorry this is a long video. Our last problem of today, x cubed plus 2x squared minus 9x minus 18 equals 0. The last thing I want to remind you of, let's get rid of this paper so you don't see the other example. The last technique I want to remind you of is factoring by grouping. Sometimes when you have cubic equations, we don't know how to solve them by hand. But if there are 4 terms, every once in a while, not always, but every once in a while, we can factor by grouping. How we do that is we look at the first 2 terms, the second 2 terms. We take out the GCF here. We take out the GCF here. And if the remaining parts match, as our x plus 2's do, we can factor those out. So we factored that, we're left with x squared minus 9. I'm not done, but I'm hoping that rings some bells. Go through that slowly. But to finish this problem, we have x plus 2. X squared minus 9 actually factors. We did this yesterday to this. So our solution set, being careful, write your work, don't be lazy like I'm being, is negative 2, negative 3, and 3. Okay. Tonight for homework, it is listed on Google Classroom. You're going to have another Math Excel assignment, also due Sunday. And then I have a Flipgrid. So if you could sign into Flipgrid using that link, click on the link in your Google Classroom. There should be a topic there for you to make a quick video just to introduce yourself to me so I can hear everybody's voice and see you talking to me. I would like that to be done for Friday so I can watch it before class. That is my hope, but if we can't get into Flipgrid, then we'll tackle that problem on Friday. So, thank you for watching the long video. In the future, if I have to do these, you can always play things at 1.5 speed if you want to get through things faster. You can skip over the parts that you definitely know how to do. But yeah, if you have questions, send me an email. Hopefully we can get together today to go over how to do stuff. So have a great rest of your Wednesday. I'm hoping you're feeling stress-free. I'm a little freaked out that I have to get all this work done, but I'm hoping you're feeling I'm doing an okay job. Second day in for us. So yeah, have fun doing all of your asynchronous learning today.